Let's take a look at this question. A trolley of unknown mass is pushed up a frictionless inclined track with different initial velocities, and the kinetic energy of the trolley is determined for each velocity by seeing how high up the slope the trolley travels. The kinetic energy of the trolley for each initial velocity is provided in the table below. So we've been given this table. Question 6.1, write the value that is missing from the table to 2 decimal places. So the missing value lies in the column of v squared. So all we need to do is take the velocity and then square it. So that block is going to be 1,26 all squared, which is equal to 1,59, and we don't need to put the unit. The data from the table has been plotted for you on the graph on page 19, so that's on the right hand side. Use the graph to answer the questions below. Question 6.2, plot the point that is not plotted with the value that was missing from the table. Now, my grid lines are a bit unclear, so I'm going to have to do some estimation here. But when the kinetic energy is 0.41, so 0.41 is about here, then the v squared value was 1,59. So 1,59, I'm going to say, is approximately here. So where those 2 points meet, that's where my cross is going to go. Question 6.3, draw the appropriate line to represent the relationship between kinetic energy of the trolley and the squared velocity of the trolley. So I'm going to use red here. And what we're trying to draw is essentially the line of best fit. So, okay, it's gone a bit off. Let's try it again. Yeah, so something like that. Question 6.4, calculate the gradient of the graph, show all your working and the points that you use on the graph. No unit is required. So I'm going to use the first value. So this is going to be the first value. So the coordinate here is going to be 0, 2 and 0, 0.05. So that's my coordinate, because this is x and that's y. Then I'm going to use the last value, so 1,80 and 0,46. So to calculate the gradient, I'm going to say 0,46 minus 0,05 divided by 1,80 minus 0,2. And that gives me an answer of 0,25625. They don't say how many decimal places, so I'll leave it like that. Question 6.5. Hence, determine the mass of the trolley. So we start with the equation of kinetic energy, which is EK is equal to half mv squared. We've calculated the gradient, which is essentially EK divided by v squared. So EK divided by v squared is equal to half m. Now EK over v squared we calculated as 0,25625, and that's equal to half m. Now we cross multiply, we'll get m equals 0,5125 kilograms. Now question 6.6, use the graph to determine how fast the trolley was moving when it had a kinetic energy of 0,28 joules. Show how you arrived at this value. So again, I'm going to have to estimate. So 0,28, I'm going to say is roughly there. So bring that across and then bring it down. So when you bring it down, I'm going to say roughly, it's approximately 1,1. So the v squared value is going to be 1,1. So that means the velocity is going to equal the square root of 1,1, which is equal to 1,04 meters per second. Well, 1,04, 1,05, so roughly around there. And in question 6.7, briefly explain why the kinetic energy was plotted against the squared velocity and not the velocity. So we look at the equation EK is equal to half mv squared. This is a constant, K. This is plotted on the y-axis, and that's v squared on the x-axis. So this resembles a y equals kx graph. And y equals kx is a linear graph. And because it's a linear graph, we can calculate the gradient. If we had to plot against v, it would not be a linear graph, and so we wouldn't be able to calculate the gradient. That's it. Thanks so much for watching. Don't forget to leave a like, share, and subscribe. I'll see you all in the next one. Bye.